Hello class, I'm going to finish up the PowerPoint on energy, or types of energy. Where I left off on, I could go back real quick, was talking about nuclear power plants. I think today in class we'll talk about, or we should have talked about nuclear power plants, how they're bad, how they work. Where we left off on was the accidents in 3 Mile Island and Chernobyl where we had a nuclear meltdown and radiation spread everywhere to the point where there was an increase of cancer birth defects. So some of you may be wondering, how do we manage the waste then if there are accidents? There's 3 types of waste management that you need to know. One's called low-level radioactive waste. So waste materials contain sufficiently low concentrations or quantities of radioactivity so as not to present a significant environmental hazard if properly handled. So we're talking about some of the waste from that nuclear reactor video I showed you last time. It's considered low-level, or they spread it out so much in low concentration that it wouldn't hurt anybody. Transuranic waste, it's radioactive waste consisting of human-made radioactive elements that's heavier than uranium. So remember, uranium is what the rod is made of in the nuclear reactor. So we're talking about contaminated clothing rags, tools, so things that you use to work in a nuclear reactor. That's called transuranic. And the last one, which is the one we're really concerned about, is called high-level radioactive waste. So it's extremely toxic nuclear waste. Such as the spent fuel elements from the commercial reactors. And the big question, especially since we are environmental scientists, is how do we get rid of it? Well, we could bury it underground, which some of you may think of. We could dispose it in space, so let's just take it up to space and bury it on the moon. Bury it in ice sheets. Dumping it in the subduction zone. Some of you may not know what subduction zones is. It's an area where you have 2 tectonic plates and one is sinking into another. So it's a situation where almost like you have a trench and it's melting into the core. So like, what if we dump it into basically lava? Bury it in ocean mud, or find a way to convert it into harmless materials. So the best one that we came up with was, let's bury it underground. The most famous one, this is also comes up on a lot of AP exam, you need to know the term Yucca Mountain. It's in Nevada. And everybody said, it's far away. It's a perfect place where it's far away from people. There's nothing really there that's useful. And why don't we just bury it there? And there's no volcanoes or earthquakes, so, let's just bury it in Yucca Mountain. Well, it was being considered for years for nuclear waste, and then actually just this year, President Obama canceled it because despite it being sort of not dangerous to anybody and sort of far away from people, you never really could be sure. I mean, we're only an earthquake or a volcano eruption away from having nuclear waste just spew everywhere. So for environmentalists, this was a very big win. The next alternative energy, so we just did nuclear power. Next one is solar energy. I'm pretty sure most of you are very familiar or know what solar energy is. There's a difference between passive and active solar energy systems. Passive means direct use of solar energy through architectural design to enhance or take advantage of natural changes in solar energy that occur throughout the year without requiring mechanical power. Or you could focus on doesn't require power. So a passive solar energy system, you put a solar panel and you don't have to power it to take in sunlight. This is just a quick question, and we'll talk about it in class anyways. So in the United States, we would place our windows, or if we wanted solar energy, where should we place them, in which direction? Active solar energy, you could tell it's probably the opposite of that. It's direct energy. Direct use of solar energy requires mechanical power or pumps or machinery to circulate air, water, fluids from solar collectors to a heat sink where heat may be stored. So maybe it moves, it pumps in, and finds a way to take in more sunlight. These are different types of solar energy. We have solar collectors, so they provide space heating or hot water. Photovoltaic, these are the ones you probably know the most of, like the solar panels you see on people's roofs. They convert sunlight into electricity. Power towers, thinking of it as just giant towers that provide solar energy. Solar ponds, so they're literally almost like a pond with some sort of solar technology that helps heat the water a little bit. And then ocean thermal conversion, it uses the whole ocean. Maybe, the ocean itself is vast. 70% of the world is covered in water. What if there's a way, the sun shines on it all the time, maybe there's a way we could use it to collect solar energy. The next alternative energy we're talking about is hydrogen. The cool thing about this is you may have heard of cars that are powered by hydrogen fuel cells. And just recently, Apple is thinking about using hydrogen fuel cells to power their laptops or maybe iPads in the future because they last for like 2 weeks. So think about your cell phones and your iPods and how it takes forever to charge or how it drains really quickly. Imagine having a hydrogen fuel cell that and the battery lasts for 2 weeks. This is fuel generated by the sun, and same thing, they're fuel cells and they use and they store hydrogen. So not much about it, you just need to know that it exists. Water power, or I think in your paper it says hydropower. So I remember in a nuclear reactor we use fission and makes things really hot and that steam spins the turbine. Well, how water power works is why don't we just put the turbine to flowing like a waterfall almost, or when you build a dam, so that the flow of water will spin the turbine. So it's a form of stored solar energy, and it's actually one of the world's oldest and most common energy sources, and they vary in size. Tidal power, almost the exact same thing as hydropower, except for this is in tides. Some of you have been in a tide before, have seen high and low tide. Their logic is if every day we switch from high to low tide, we have this rush of water that could be used for energy. Wind power, you may have seen this driving in California. I don't know if you've seen those giant wind turbines. Here's some pictures right here. And depending on where they're located, so here's at the top of a mountain, or here it's in between two mountains, and when the gush of air flows through that gap, the strong winds push these turbines. So it's actually been used for centuries, and more recently, thousands of windmills, again, as close as California, have been installed to produce electric energy. I posted an article on Twitter. I don't know if I'll get to it in class, but some people have complained that wind power actually wastes more energy than creates energy. Biomass is another alternative. So we talked about solar, nuclear, water, wind, and now biomass. Biomass is probably the one that you know least about. Biomass is energy that's recovered from biomass, which is organic material, plant and animal waste. So we're talking about, to make it simple, using poop, or how about this? We could use wood logs, charcoal, agriculture waste, timbering waste like branches. Here's where we talk about animal poop, aquatic plants, and then urban waste like paper and cardboard. We could direct burn it or convert it into biofuel such as natural gas, which we talked about earlier, or biofuel such as ethanol, methanol, gasohol. That's called biomass, where we take things that are living things like wood or poop, or was once living, or made from living things like paper and cardboard, and converting it into energy. And the last one for this PowerPoint is geothermal energy. We're talking about, you may have seen these, they're called geothermal vents. We've talked about it in the ocean before, like smokers, those black vents, the black smoke that come out of vents at the bottom of the ocean. This one's like above ground. You may have heard of like hot springs before. So natural heat from the interior that's converted to heat buildings and generate electricity. So they could even use this stuff to power something, which is pretty cool. So it's a shortened version of our PowerPoint. I just wanted to finish it for y'all today and not do it in class, and we could do some more, do some activities. So hope you enjoyed, and I'll see y'all when I see y'all.